56,000 employees. This is our R&D spending, our patent stock, and the sites where we are in the world. Number of greater than 2,200. ThyssenKrupp has 6 business areas, which you see here. First is components technology, and inside this business area we closely work together with the automotive industry. So we are an original equipment manufacturer for many parts in automotive industry. There in this business area we also build gearings for wind power plants and something like this. Elevator technology, one of the most famous business areas, I believe, of ThyssenKrupp. And if you don't take the stairs to the 3rd floor here in this hotel, then you also used one of our lifts. Interesting technology in this business area is the so-called multi or twin. So you have 2 cabins run in one shaft without ropes. It's a very interesting technology because space of buildings is important and costs money. And so now if you can run more of this cabins in one shaft, of course you can save space. First installation will be in Germany, in Berlin. Material services as a 3rd business area. Here we sell all our products we produce and also products of 3rd parties. Then our activities in the steel business, Steel Europe, and at the moment Steel Americas. Steel Europe, maybe the most known asset is our steel plant. We operate in Duisburg here in Germany, and this is the biggest integrated steel mill in Europe with 12 million tons of steel production capacity every year. And last but not least, the business area Industrial Solutions. That's where I'm from. And we are a partner for designing, engineering, and construction of all kind of industrial plants. And I will go in a little detail what we do in this business area. In this business area, we build machines for different industries. You see here cement, you see mining, you see fertilizer, chemicals. We also build submarines and other marine yards. We are a supplier for the automotive, the aerospace industry, and also for the steel industry. And based on this, we build at the moment approximately 2,500 plants in this field, and have at the moment in fields approximately 7,000 or a little bit more than 7,000 machineries. Of course, this is all covered by a service concept, so we don't leave our customers alone. In case they want to optimize their plant, they want to do revamp of their plants. We are in close contact with them, and we call it the 360-degree service concept. And inside our business area, Industrial Solutions, we have 8 business units, which you see here. One is electrolysis and polymers. Here we have own technologies, for example, for water electrolysis, for energy storage solutions called redox flow batteries. We are market leader in chlor-alkaline electrolysis. We also build plants and have own technologies for polyester, for polyamide. We build polylactic acid plants as renewable feedstock and have an own technology, only to mention a few. Then we have our fertilizer and syngas technologies. The most important fertilizer so far is urea, and there we also have an own technology for ammonia, but also build plants with respect to sulfuric acid, phosphate fertilizers, ammonium sulfate, nitric acid, and also on. So the whole chain of fertilizers based on nitrogen, phosphate, phosphorus, or sulfur. Inside our BU industrial specialties, we have our technologies for refining technologies and also coke plant technologies. So we build the coke plants for the steel industry. Cement technologies is clear. Mining technologies is also relatively clear. Then we have our service business unit, which I also mentioned before, system engineering. There we build production line for the automotive industry, and also production lines for lithium-ion batteries, and then our marine systems business unit for submarines construction and designing of other marine yards. So we are a very diversified company and much more than only doing steel. Inside this, I told you, we have own technologies. We also have own catalysts, of course, for this for the petrochemical industry, which is maybe not known, and maybe that's also the reason why I'm here why I'm here today, because we have a very close relationship to the chemical industry. But this I want to introduce. And the subtitle of my presentation is the Fourth Industrial Revolution, and that implicates that there were 3 other industrial revolutions before the fourth. And I had a look in our archives and found some interesting pictures. So the first industrial revolution was the development of water and steam-driven machines. And here you see a picture from ThyssenKrupp. This is a steam hammer called Fritz we installed in 1861. And of course, by installing of this, which was by far the largest machine of this, with a blow of 50 tons in this year, and also for a longer time, we increased productivity really a lot. And the name Fritz behind it, there was a very smart machinist to run this plant, and he was called Fritz, and that's why this machine was called Fritz. Don't know if it's really true, but at least it is a nice story. The second revolution is Taylorism, or increasing economics of production, and of course decreasing labor costs. Here you see a Grasmauer assembly in an agriculture machinery plant from 1930, and by this, of course, production times were reduced drastically. And I will show you later on how this affects the industry. The third industrial solution then is automation. And here you see a picture of 3 welding robots that were installed at ThyssenKrupp. And by this, of course, the average hourly labor cost was also decreased drastically. Now we come to the fourth industrial revolution, digitalization, Internet of Things, whatever you call it. And I think we all have in mind that it will really change the way we live, work, and relate and communicate. And we see day by day that there is really much is ongoing. And that's the way we communicate, and the information availability of information is much more different than a few years ago. To summarize this, first industrial evolution, the steam machines. So productivity increase by a factor of nearly 60 in the early 19th century. Example is here the pig iron production in England. The second industrial revolution, example is here the Ford T chassis production, and here the production time was increased by nearly a factor of 8 by doing this or installing this assembly lines. And the third industrial revolution, then the robotics, and here you have an average reduction of the hourly labor costs or wage costs, and by far, of course, also an increase in productivity. And now the fourth one, and we all know that we are in the middle of the fourth one. To be honest, we don't have a clear picture what will happen, and there will be some surprises in the future, for sure, that we have to act on or react on. But we have an idea how we inside ThyssenKrupp Industrial Solutions want to challenge or want to face the challenges that come on, and this I will show you in the next slides. At the moment, approximately 1,000 employees at Industrial Solutions are working on electronic systems and controls and automations. So approximately 5% of our employees doing works or their daily work is in this field. I showed you that we are very diversified. And we divided all these things of digitalization into 3 technology clusters. These 3 technology clusters are the digital factory, data management and analytics, automation, plus and smart technologies. And the idea is that we want to find one common solution for our business area. Because data, if it comes from a fertilizer plant or from a cement plant or whatever, they are data and they can all be analyzed using the same tools. And this is what we want to do. So a solution, one fits all, and also doing visualization, of course, for our customers that they have the same look and feel, which is independent on the technologies that we really serve to the customers. What is meant by this, you see here on this slide. So digital factory, this is all about our engineering tools. So new engineering tools we want to implement, for example, a digital twin. I will show you on a later slide what's this about. It's also about simulation of operator training, so installing digital or virtual plant and then do operator training by using this plant. The next thing here is data management and analytics. So generate, merge, analyze field data and create value out of it. That is always good to create value out of it. And of course, there are a lot of technologies and tools in the market. So we do not develop this by our own, but we go to the market and look for technologies that are available to analyze the data. And this is by far also the most important thing with related to the presentation title, because we don't run plants by our own. So the plants are all at our customer sites, but of course we have engineered, designed the plants, and we have the know-how how these plants will work. So if we bring, and this is the idea what we want to do, customer where the data where the data are, and our process know-how bring together, and then in a cooperation, of course, then bring this to an added value for both sides, of course. Last, automation plus and smart technologies. So here, for example, at the beginning of this month, we started our technical center, additive manufacturing in Germany. So it's some kind of startup. It's an internal startup, but it's independent from the organizatorical of or from the organization, from the big organization, and this is due to because there are some people, they need to be agile, flexible, and they get some time and money, and as an internal startup, they can work on these things with respect to additive manufacturing and 3D printing and also on. Another thing here is HoloLenses, service with respect to HoloLenses. This is also a topic where we are very active. And this is what I mentioned before. So the data are generated at our customers. There needs to be an exchange between the data, between our customers and us. Of course, this is issues are trust. We need a close relationship. Of course, security is an issue. So there are also things in the market and companies in the market that know all these things much better than we do. So here we also go to external suppliers. But the data analytics then is done by us. Of course, this is also a living system. When we get the data and have new tools, engineering tools or new training tools or whatever, and use other technologies, then of course the amount and the quality of the data will change, and then of course when the data come back to us, it will be adapted or needed to be adapted at this site. So this is a start, what we do, but we know this is a living thing where we have to work on the next years. What is the customer value, or what is our value? Of course, it's an increased overall efficiency. It's an increased total cost of ownership. Time to market with respect to new installation can be decreased. This, of course, in relationship with a higher quality and higher transparency. Easy to operate systems, this is also very important, and this is what I meant when I talk about make the results of the data analytics visible. So the results need to be, or the management as well as the operator of a plant needs to understand the results of the analytics. And so we are working very hard on a way to visualize the results to the customer for an easy operation. Of course, climate protection is always important. Sustainability products. So the idea is, of course, to reduce or to increase the energy efficiency of our products as well as the floor space. And which is also a customer requirement is that all these systems are need to be possible for ramp up or scale up. So one time installed all these systems at a customer site, of course, it should be possible to adapt this to future needs if the amount of data, the sensors, whatever is behind it change, and the quality of the data changes, then of course this needs to be adapted. And the last thing, of course, is our customers as well as we want to add value to this, and we heard this in the morning. Innovation is transferring ideas into money, and this is what is behind this. Here's one example what our customers really request from it, and this is a digital twin. In these pictures, I think it's a Smart for 2 production line. Shown here. So this is the reality as built. This is the digital model, and we are in very close contact with our customers right from the concept and design phase till the as built phase, and all the steps in between. And of course, if there are something changes at customer sites, then this model needs to be adapted to this. Last slide is my summary. So I think you learned, or I hope you learned, that ThyssenKrupp is doing much more than only steel, and that we are focusing on 3 areas with respect to digitalization. And this we also heard in a lot of talks this morning. It is not easy to implement a digitalization strategy in a big company. It needs a culture change, it needs education, and it also needs a new business model that we also heard before. We do a lot of training for mindful leadership inside our company, but training is the one thing. It has to be implemented in the whole organization, and that is not an easy task. And the benefits, of course, are clear: reduction of costs and higher flexibility and higher quality. This is what we want to reach with this. With this picture, also fields that we are active in. It's a human-robot collaboration for the automotive industry. I want to thank you for your attention, and hopefully you have some questions. Thank you.